Hi everyone. So in the previous video we have studied about introduction to programming. We have studied about statically typed language and dynamically typed language. There are two types of languages, statically typed and dynamically typed. We have studied that in statically typed, type check is done during the compile time. In dynamic typed, type check is done during the runtime, and it will give error during the compile time. Dynamic type, it will give error during the runtime. And it does not we don't do not need to specify any data type while writing the code, and here in statically type we need to define any data type while writing the code. And here we can change the data type also in the next line, as we have seen in this example, but here we cannot change the data type, and it has already been declared of any given data type now. So we have the examples also, this for statically typed and this one for dynamically typed. Okay, so we have done the recap for the previous video. Now today we are going to study about stack memory and heap memory. Stack memory and heap memory. So what is a stack memory? Okay, so I cannot draw anything here, but just visualize. We have sorry, a we had that a now int a equals to 10. Okay, so I'm just writing a equals to 10 right now. So a is a variable. And what is 10? 10 is the value that is assigned to the variable a. Okay, so a is a variable, and what is 10 then? 10 is a just a value? No, it is called an object. We can say that 10 is an object. Now in memory, in which memory? The main memory. What is the main memory? The RAM. In the RAM, where are these two things, this variable a and this object 10 is stored? Okay, while writing a code now, there are two kinds of memory. There are many kinds of memory, but for assigning these two things we have a stack memory. What is a stack? Stack is nothing. If you see, let me do something if I can do. And we have this thing. Yeah, yes, I'm good at drawing. So this one, sorry, this one. Okay, this is called a stack. What is this? You don't understood? No, let me talk. What is this? See, stack is something. If we store, let's say one here, sorry, two here, two here, two here, three here, and four here. Okay, so in a stack, the first element that we inserted was 2. The next second element was, let's say, 10. No, 9. Okay, the third element was 3, and the fourth element that we inserted was 4. Okay, so this is the structure of a stack. It is open from the top and closed from the end. Assume a stack of books. You are keeping books. This is the first book you are keeping, the second book, the third book, and the fourth book. So at last, which book is accessible to you? The fourth one, the topmost book. You can access it without removing the down book. Okay, the easiest way to access the book is the topmost book. Okay, so this is called a stack data structure. Now if you remove the first element, what is the leftover? The top one is 3, the 3 is left. And now if 3 is removed, 9 is left. 9 is removed, 2 is left. So this is called a stack memory. In stack memory, what kind of operation is followed? LIFO or FIFO. The first in, first out. Sorry, FILO. First in, last out, or last in, first out. The last which one entered, the last entered here, and it was exited at the first time, at the first only. At last, here we have 3. I think we had 3 or 4, and it was removed at the first because it was the topmost element. It will be removed first, then the next element, then the third, and then at last the last element. The first element which was entered will be removed at the last, and the last element which was entered will be removed at the first. So this is the operation of stack memory. Now, in stack memory, we have this variable is stored in our stack memory. Let's say a is stored in our stack memory, and this 10 is stored in our heap memory. So what is a heap? Just imagine a heap of hay. Hey, you just search it over the internet. Heap is a mountain kind of structure, hill kind of structure, and here the 10 value is stored. Okay, so why do we study about stack data structure and heap memory? Because the a variable is stored in our stack, but it does not have this 10 value, because 10 value is stored in our heap because it is an object. Any object is stored in our heap value, and any variable is stored in our stack memory. Do remember that this is a point to be remembered. Any variable is stored in our stack memory, and any object or any value is stored in our heap memory. Be it RAM or whatever, any value will be stored, any object will be stored in our heap memory. Now, the a is in our stack memory, which will point to this value 10 in our heap memory. Let's say heap memory is just beside here the stack, and it will point to 10. Okay, I cannot draw, but just imagine a is pointing to 10 with a pointer. Okay, an arrow is pointing to 10. Okay, now is pointing to 10. Now when we want to access the value of 10, this address of 10 in the heap memory will give back this value, and we are watching this value in our program. Okay, so that's how stack memory and heap memory works, and that is the importance of stack memory and heap memory. So this is the basic funda, and no, not much more you should study right now, because for general programming and data structures, this much of the knowledge of stack memory and heap memory is enough. Okay, now one another thing I want to discuss. If you have the knowledge of classes and object, okay, there are also any object which will be created. Let's say this is not 10, any object, let's say just assume any object. We'll discuss the example later on in the next videos. We have this any object, that object will also be stored in our heap memory. Okay, now here what is the type of this object? This object is of type integer. Okay, so where will this type will be stored? Type will still be stored in our heap memory only. Why? Because this type is only the value. The 10 is of type integer now, and it is stored in our heap memory. And here let's say we have another value, another variable b. B also has a value of 10. So where will b point? B will again point to the same 10 in our heap memory. Okay, because in heap memory we will not create uh, we will not sorry, what we say, we will not do duplication of data in heap memory. Duplication of data is not allowed, but here in the stack memory we can create multiple addresses of for multiple variables, but that variables will store will point to the same values in the heap memory as according to our requirement. If we want to point to 10, it will, the a will also point to 10. Now if you want b to point to 10, so b will also point to 10. And if you want c to point to 20, then c will point to 20. 20 will now 20 will be added to our heap memory. So that's how stack memory and heap memory works. Now, can we have more than one reference variable? What is a reference variable? This only reference variable, like C is referencing to 10. So can we have more than one reference variables pointing to the same object? Yeah, we have this A and B pointing to 10. Okay, the same object A is also pointing to 10, B is also pointing to 10. So we have more than two reference variables pointing to 10. Now, what if one reference variable changes the object? Hmm? Let's say a changes to 20, a will point to 20. So will b will change pointing to 20? No, because b is only now assigned with this value 10. Okay, if one variable changes the object, the original object will still be there, because the B is also pointing to the 10 in the heap memory. Let's say A is pointing to 20 and B was also pointing to 20. Now A is pointing to 10. Now will B again point to 10? No. Why will it change to 10? Because just A has changed. B has not changed. So there will be no change. So if one variable changes, so other variable will have no effect on it. Okay. Now, now what will happen if A changes? A points to 20, B points to 20. Forget C right now. A points to 20, B points to 20. In the next time, A points to 10 and B also points to 10. So what will happen to that 20? The 20 will be given to the garbage. So now 20 is a garbage value in the heap memory. So it will be collected by the garbage collector. And what is a garbage collector? Any value that is in no more use, which is a garbage value. Let's say here B was, sorry, here the 10 is a garbage value because both A and B are pointing to 20 now. So the value which is in no more use is now given to the garbage collector, and garbage collector will throw the garbage value out of the heap memory. So that is the use of garbage collector. So in this video what we have studied about stack and heap memory, garbage collector, and what more, we have studied about reference variables. What are reference variables? Nothing. The normal variables are only called reference variable. They just reference to the given variable, given object in the heap memory, stack memory. And so these three things we have studied in this video. I hope this video was informative to you all, and thanks for watching.